students, in the last classes we discussed about what is clinical thermometer. Clinical thermometer. Then we discussed how to convert a value from degree Celsius to degree Fahrenheit or something from degree Fahrenheit to degree Celsius. These are the last topics. Today we are going to discuss what is laboratory thermometer. Laboratory thermometer. Laboratory thermometer. As its name, we use this thermometer in laboratory. Now, I am taking a beaker and filling it with water, and I am giving here the heat. That is, I am just putting a candle here. Then what happens? This water starts to get heat, and after some time it will boil. So now the temperature of this water is 100 degrees Celsius. That is, the water gets boils. Now the thing is, I want to measure the temperature of this water. How I can measure this? Is it possible to use the clinical thermometer? That is the question. Is it possible? In the last class, I said you that there is a limit for this clinical thermometer, and this 100 degrees Celsius is not in that clinical thermometer. So, we are going to measure this 100 degrees Celsius using our laboratory thermometer. That is, this laboratory thermometer is a long glass rod which having mercury inside, which contains mercury. I already explained why we use mercury in thermometers. Now, when this temperature gets increased, what happens? This mercury will rise. That is happening in this thermometer. Now, the question is, how we can measure the reading using this laboratory thermometer. This is our thermometer. Now I am doing that. I am taking this thermometer outside this beaker. What happens? Is this reading will be same inside this water and outside? What is the thing? The thing is that now I am again putting this thermometer in this water. And you please care that this thermometer do not want to touch the sides of this beaker. Now I am putting this thermometer like this. For example, I am taking a pencil beyond this thermometer. Now this thermometer is I am putting in this beaker. Now this thermometer is not touching its walls and it is inside this water. When this thermometer is put here, the reading will slightly move up. When this reading will steady, then we can take the reading. I am keeping this, and at an instant this 100 degrees Celsius will be constant. Then we can take the reading as 100 degrees Celsius. Or if the temperature of this water is 80 degrees Celsius, this thermometer will read 80 degrees Celsius, and I will take this 80 degrees Celsius inside this water. The question is that when I take this outside, what happens? This thermometer reading will go down. What is the reason? In our clinical thermometer, there was a thing called nick. There was a nick. And this nick helps to don't fall the reading down. But in our laboratory thermometer, there is no nick and the reading will automatically falls down. So if we want to take the reading, we want to put this thermometer inside the water and we have to take this reading. This is the method how we can take the measure using laboratory thermometer. This laboratory thermometer is the thing in our laboratory and we will show it from your school. This is the first thing. Now, in the last class, I told you that for every thermometer, it have a lower value and upper value. Now the question is, what is the lower value and upper value of our laboratory thermometer? The lower value is minus 10 degrees Celsius and the upper value is 110 degrees Celsius. That is, within this limit we can take the values of our temperature. The lower value is minus 10 degrees Celsius and the highest value is 110 degrees Celsius. You please want to note these values. These values are important. Now, the question is, which thermometer we are using to measure the weather? We can see that the weather today is 29 degrees Celsius and for a value of 45 degrees Celsius. Like something we are seeing in newspapers or our TV channels. Why it is showing like this? For the weathers, we are using a minimum maximum thermometer. We are using a maximum minimum thermometer. Maximum minimum thermometer. That is, for this weather we have a higher value and lower value. It says that our lower temperature will be this and the higher temperature will be this. So you please note the maximum minimum thermometer, the name. Okay. I think the section is clear for you. Now, the thing is that I already told you that we are using mercury in our thermometers. But the problem is that this mercury is a toxic substance. It is a toxic means poisonous substance. And when this thermometer got break, then this will make harm to our body or it will cause some problems in our body. So, because of that, we invented a new thermometer called digital thermometer. Digital thermometer. Here we have a digital thermometer. Here you can see this. I think you can see this closer. And here we have a button. For on this we just press this button. It sounds a beep sound. This is the digital thermometer. Here we can see the digital values here. Here a digital value will show. And here this is the sensor. By using this we can measure the temperature as we can put this here and hold this like this. And it started to give reading. And we want to put this for a long time, and when this instrument started to beep continuously, that is the constant value for our temperature. So it needs some time, and when I keep this for some time, this started beep sound and we can get a constant reading. Now you can see here it shows 94.5 degree Fahrenheit. Using this digital thermometer we get in degree Fahrenheit unit. So like this we are taking temperature using the digital thermometer, and this is the device. I think it's clear for you. And these all are about our topic thermometer. We discussed clinical thermometer, laboratory thermometer, and digital thermometer. Now you can hear the beep sound. It is the constant body temperature of my body now. It shows 94.6 degree Fahrenheit. Okay. Now we are going to next topic. The next topic is transfer of heat. Transfer of heat. The question is how this heat is transferring from one body to another. We know this heat is a form of energy, and we know that we can't create energy or destroy. Energy can neither be created nor be destroyed. It can be only transferred from one object to another. So, for example, I am taking two beakers. In this beaker, I am taking water of 60 degrees Celsius. 60 degrees Celsius. And here I am taking water of 20 degrees Celsius. Now I am doing that. I am going to mix this water in another beaker. I am taking another beaker and filling this both of liquids to here. Now I am just simply drawing this here. It will be 60 somewhere and 20 like that. It will mix. How this mixing is happening, that I am going to explain. Now here, when I am first giving this 20 degrees Celsius, then it is here, and then I am giving this 60 degrees Celsius water. Then what will happen? Do this 60 and 20 will remain like this always? No. What happens? Here the heat will flow from somewhere to somewhere. The question is, this heat will flow from where to where? You know that this heat will flow from 60 to 20. That is, the heat is flowing from higher temperature to lower temperature. So, after some time, what happens? This liquid will mix and we get a temperature of 40 degrees Celsius together. 40 degrees Celsius. That is, what is happening here? It is the average. That is, the 60 and 20 get mixed and this 20 get this extra heat. And when this get a equal value, then no heat will flow from one to another. You just want to understand that when we are mixing two bodies having different temperature, the heat will flow from higher temperature to lower temperature. That is happening here. This is the first point. So, we said that the transfer of heat is happening from two bodies having higher temperature to lower temperature. This is the first example. Now we are considering another example. I am taking a utensil. Now I am giving fire. This is fire. And what happens? Here this utensil is first, it's cold. We know in each and every time the heat will transfer from higher to lower. Now this beaker is in lower temperature or cold, and we can say it as, here this beaker will get slightly hot. That is, here the temperature will flow from this to top. Now here the transfer of heat is getting from lower to upper by this utensil. This is the transfer of heat. And now I am going to remove this heat. I am going to remove this fire. Now what happens? Now this beaker or our utensil is hot. This is hot. And what about our surroundings? These are cold compared to this utensil. Now what happens? This hot will sustain for whole day? No. This utensil will lose its hot after some time. Where this heat will lose? This heat will transfer to our surroundings. That is, this higher temperature body loses heat to our atmosphere. Here also what happens? The heat is transferred from higher body to lower body. I think it is clear for you. Now we are going to discuss that how this heat is transferred in a body. In your textbook there is an experiment. They took a iron rod and sticking here wax pieces. And just fix it in this side, and I am giving fire on this side. I am heating it here. What happens? Is this wax will fall first down? No. When this gets heated, we are heating here. We know this end is cold and now this end is hot. Now our heat will always transform higher to lower. So first it will fall down this wax piece. Then this will fall down. Then this. So we are here concluding that heat is always transferred from higher body to lower or higher temperature to lower. So this is an example which is explained in your textbook, and I will give you a video later for more explanation. So now I am explaining that here we used iron scale or metal scale. This is metal. If I am taking here a wooden scale, is it possible to fall this down? No. Why is it so? So this metal have certain properties to conduct our heat rather than our wooden piece. So what is the reason? So only certain substances can transfer heat. So this transfer of heat is called conduction. It is called conduction. So how we can explain this term conduction? It can be explained as the process by which the heat is transferred from the hotter end to the colder end of an object is known as conduction. Repeating, it is the process by which heat is transferred from hotter end to colder end of an object is called conduction. I hope the definition of conduction is clear for you. Now we are going to do a simple task. I am taking a beaker and fill it with water and boiling it. Then the 100 degrees Celsius is its temperature. Now I am going to do that. I am putting some spoons in it. That is, the first one is metal, then copper, wood, plastic, steel. Like different materials, spoons are putting in this water. What happens? I am putting a spoon here. I am putting a spoon inside here. Then after some time, when it is, this metal is iron. Now if this is iron, after some time what happens? This spoon will get higher temperature and I get burned my hands. This is the thing we want to measure in this experiment. I am putting this copper, wood, plastic, steel, all spoons inside this beaker, and do this plastic spoon get hot? No. And what about this wood? This wood also will not get hot. Then what is the reason? This metal, that's iron, copper and steel. Iron, copper and steel get heated, but the wood and plastic do not get heat, or they do not get hotter. Then what is the difference between these substances and these substances? That is a question. And now I am going to classify the substances into two according to this property. That is, I am classifying it into two. The first one is conductors, and the second one is insulators. Conductors and insulators. So what is this conductor? Conductors are the substances which transfer heat is called conductors. And what are the substances called non-conductors? They are the substances which do not conduct heat. The examples of these insulators are wood and plastic. The examples of conductors are iron, copper and steel. So I think the explanation of conductors and insulators are clear. Now, today we explained different things. In the next class, we will discuss how this heat is transferred in water and air. The question is, do this water and air is good conductors or bad conductors? We can call these insulators are bad conductors. Bad conductors. The question is, air and water are conductors or are bad conductors? Now you please read your textbook and find the answer. And in the next class we will discuss how the heat is transferred in water and air. It's enough for today. You please want to complete your notebook